So we need to find the Taylor series for the given function centered at a equals 0. We need to write the first three non-zero terms of this series and write it using summation notation. So the general term of for the Taylor series f of x equals the sum of the nth order derivative of f of a over n factorial times x minus a to the power of n, where n goes from 0 to infinity. In our case, since a equals 0, this equals the sum of the nth order derivative of f of 0 over n factorial times x to the power of n, where n goes from 0 to infinity. If we expand it, it becomes f of 0 plus f prime of 0 over 1 factorial times x plus the second order derivative of f of 0 over 2 factorial times x squared, and so on. So we need to find the values of the derivatives at x equals 0. So f of x equals the inverse tangent of 4x, then f of 0 equals 0, f prime of x equals 4 over 1 plus 16x squared, then f prime of 0 equals 4. The second order derivative of f of x equals negative 128x over 1 plus 16x squared. So the second order derivative of f of 0 equals 0. The third order derivative of f of x equals negative 128 times 1 minus 64x plus 16x squared minus 1024x cubed divided by 1 plus 16x squared cubed. Then we get that the third order derivative of f of 0 equals negative 128. So our Taylor series for this function becomes the inverse tangent of 4x equals 0 plus x times 4, so 4x, plus x squared over 2 factorial times 0 plus x cubed over 3 factorial times negative 128, and so on. So this equals 4x minus 128 times x cubed over 3 factorial